I think we're ready to get started, everybody. So just a quick reminder, if everyone could turn off their cell phones, turn them on vibrate, that'd be great. In this session, we have 5 companies presenting. You're in the CleanTech session, by the way. You can read a brief summary of each of the companies in your program. At the end of the presentation, we're going to ask each of you to fill out a card selecting who you think is the most likely to succeed, and then we'll collect them at the end of the panel. Please just pick one company. And you'll have an opportunity to meet each of the companies in the networking breaks. So quickly on our panel, we have a great panel. Michael Jackson from the Wesley Group, Eileen Tanghal from Applied Materials, and Andrew Chung from Lightspeed Ventures. So as everybody I think knows, we're going to do 6 minutes of a presentation followed by 4 minutes of questions from the panel, and then we'll move on to the next one. So the 5 companies we have presenting today are Bourne Energy, Intolin, Skyline Solar, Silvatex Biofuels, and Watson. So here on deck, Don Vina from Bourne Energy is going to start us off. So 6 minutes. Your timer's up there. I'll try to keep you on track.
Thank you. Can we all hear? This is all good? All right. Hi. Good afternoon. I'm Don Vina from Bourne Energy. I'm Vice President of Design. Which button?
Good question.
Wrong one?
Yeah. Restart the timer.
Oh, there we go. Very good.
Got it?
Hey, sorry about that. It's good. Oil is a tough act to follow. We all know this, and that's why we're looking at alternative energies. In addition to this, we're finding that water and energy are closely tied together. As an example, this nation's water supply, 50% of it is used to cool our industries. And of that, you have 5% of the electricity, or 15% of the electricity of the United States is used to move, process, and dispose of water. So we all know that there are existing clean energy systems right now. We have solar, we have wind, we have thermal, we have ethanol, and then we have the dams. Now I want to take another look at the dams. This is what we have done. Dams are still, hydropower is still the cleanest form of energy that we have today. Now what we have done at Bourne Energy is that we have taken the dam and we have shrunk it down to something considerably a lot smaller. And what we end up with is our Riverstar system. We have 4 different systems available to harness the 4 different types of hydropower available, from river to ocean to wave. This is the Riverstar. This is the Tidal Star. This is the Ocean Star. And this is the Current Star. All of these units are self-contained, very compact. They're all built around a very similar technology, and the technology is in the rotors in the nacelle area. Because the technology is similar amongst all of them, they are scalable quite easily, so that we can move them up or down depending on the necessary application that we want to put it in. The nice thing about hydro is that it's very dense, and therefore the turbines and the rotors on these units do not have to spin nearly as fast. Therefore, the loads on them are considerably less. Our very first unit to market is going to be the BPP, which stands for Backpack Power System. This is a 600-watt unit. It measures roughly 3 feet by 2 by 1 in its collapsed form, weighing only 30 pounds. This is something that you can put on your backpack and take into rural areas and set up quickly. When it is set up, it takes roughly about 10 minutes to install, or 10 minutes to build, 30 minutes to install. It will generate 600 watts continuously. It measures roughly 3 by 3 by 3, so 1 cubic meter. It operates, to generate at 600 watts, it's rotating or operating in a river flow of roughly 2.2 meters per second, give or take about 4 knots, and this is continuous power. Also, these are very compact little units and very durable in allowing us to do some unique things like put solar on top if we want to combine them with solar. This is an image of what we could do with these if we put them in the LA Aqueduct. Now here's a large reservoir of water that is not used except to move water, and it has actually a current of 4 knots. If we use these in the aqueduct, we could tie it into wind power, we could tie it into solar power, and you have quite a nice generating system for generating power. The benefits and the values on this, obviously it's very easy to produce. It can generate generate revenue quite easily. And these are our market potentials. We have utilities, military, government, regeneration, remediation, and treatment. In this set, we can use these units, especially the smaller ones, we can put them in the outflow of dams, we can put them in the outflow of industry, and therefore they can capture some of that water energy that's coming out from a dam, coming out from an industry, coming out from a cooling channel, pipe it directly back into the corporation that's currently using these. Our pricing model and our product roadmap. Now what we have with the product roadmap is that we have a 4-year plan, and what we start with is we start with the Riverstar 600, which is currently developing right now. We are on our 5th version of that. That is going to go directly to the United States Navy and the Department of Energy this August. They're going to test it and give us some feedback on what they're finding with their numbers. Year 2, we'll look at doing the Riverstar and the Tidal Star system. Now, because the technology is very similar, it's very easy to scale from one to the other. Year 3, we're looking at the Ocean Star system. Now, this is a 1 megawatt system. So we're going to start testing by doing a scale model in the 3rd year. Production is going to require a bigger facility for us. 4th year, we're going to look at the current star system and start to develop that unit. This is our financial projections. Based on 4 years out, we're looking at a licensing agreement here, and we are predicting 25% growth in market share as we develop and introduce into market all 4 of our units. Our return on investment and our payback is expected to happen within these 4 years. These are our milestones. Again, what we're going to look at then is, like I said, the Navy is going to test this in August. And we're done.
Why don't you just wrap up your last?
Absolutely. And so these are very dense systems that are currently available, and we are looking for our first funding to get off the ground on these. Thank you. Questions?
So rapid fire panelists, I guess you could probably do maybe one question each.
How does the pricing compare to other options?
We are very price competitive with solar and wind. What we're looking at in developing, or as far as the price per watt, is anywhere between 4 to 6 cents per watt is what we're capable of doing. Where we end up saving money in the long run is during construction, because these are a lot smaller units. It's very similar, if you will, to any kind of other naval construction, like a boat. And therefore, these are proven technologies. The gears and the rotors and all this stuff are working at a slower speed, but these are smaller units not requiring such an investment in land or acreage, and therefore our cost to produce is a little less.
Sorry, you said 4 to 6 cents per watt? Or
4 to 6 cents per watt is what we end up coming out with in our projections.
So the 600 watt system would be $24?
No, to produce or to on the...
So 4 to 6 cents per kilowatt hour.
Yes, thank you. Yes, thank you. Sorry. Thank you for clarifying. Yes, the 600, the BPP 600 would retail for around $2,000 is what we were expecting. Yes.
You outlined a bunch of different markets.
Yes.
Which markets do you see as, it seems like the military is potentially your first go-to-market. What are their main product constraints? What do they really want to see in it from a cost perspective, a durability, a
Sure.
time to set up? What are their main features they're interested in?
Sorry. What caught their attention was the portability of this. The ability for them to haul this into a remote area and set up communications, or at least set up electricity to run their laptops or their general communications with their base, and do it relatively quick and easy was the first thing that caught their mind or their eye. The other thing is that it's portable. So it's not permanent. So if a platoon or a company has to move, they can just haul this thing out of the water and take it with them again so that there's nothing for the enemy to capture or destroy. That is their primary focus on it. Of course, what we see as well is there is a private sector for this as well. If you're camping somewhere out in the wilderness and you're by a river, you have something that can run the power for whatever you want in your tent or in your RV.
How does that work in practice? So if you're, you're trying to go for decent current, and you have to stick this thing in the water.
Yes.
Are you grounding it in some way? How are you getting the power back out? Like,
Absolutely.
How does that?
The unit is tied. There's actually several different ways that we can tie it down into the water. The most common way is that it has a high tension cable system that runs right through the dead center of the nacelle, right where the rotors are. And it ties to the right and the left of the shore through a high tension cable. You'd anchor the cable in on one side of the shore, put the unit in the water. On the other side of the shore, you can anchor it in with a winch. Just winch it into the ground, knock it in. Or you can there's a bow line that can sink it into the bottom of the river. And there's a couple of other different ideas. It really depends, the idea being that this is a modular, configurable design. We have to take a look at the river situation first, find out what the power needs are, and then from there, these can be configured to meet whatever power needs or how the anchoring system needs to be, depending on the topography.
One last question. What's your anticipated long-term gross margin for that larger market?
Meaning, I'm sorry.
Your long-term gross margin, meaning the price you think you can sell into the market minus how much it costs you to make the
Gotcha. We have projected that if we can get this into market to sell 5,000 units the first year, and that's actually a very conservative estimate at this particular time. We have a little over 400 inquiries to acquire this, so it's a matter of scaling up for that.
All right. Thanks, guys. Thanks, Don.
All right. Thank you.